Thank you all for being here. And thank you, Dr. Perdisci. So Dr. Roberto Perdisci is, I'm saying it right, is Patty and Dear Grimes Distinguished Professor in Computer Science at the University of Georgia, where he directs the UGA Institute for Cybersecurity and Privacy. He is also an adjunct associate professor in the Georgia Tech School of Computer Science and a member of the Georgia Tech Institute for Information Security and Privacy. His research interests include network and web security, malware defense, security applications of AI, IoT security, and telephony security. And thank you all for being here, and thank you, Dr. Burke.
And thanks for attending the talk. I'm happy to be here. I'm the director of this Institute for Cybersecurity and Privacy, and I will be talking about cybersecurity research and academic programs at UGA. I'm mostly a researcher, I guess, in a way. And so I will try to talk a little bit about the research that we do. Hopefully it will be interesting to you. And I think, if you're looking into especially joining a graduate program, you should really be thinking about research as one possibility, as one path for your career. Not necessarily academic research, but even if you go into an industry position, in some cases, at least in some positions, research experience is required. So I will talk a little bit about the research projects that we work on, especially one of mine, and hopefully this will be of interest to you. All right, so this is the agenda. I will first introduce the Institute. What is it exactly? And then I will talk about the master's program in cybersecurity and privacy that the Institute, mostly the computer science department, the UGA, administers and offers. And then give an very quick overview of the research topics in cybersecurity and privacy that our faculty cover and work on. And then I will go a little bit more of details about sort of like one example of project that we're working on studying and defending against social engineering attacks on the web, and I will explain what that means. And then talk a little bit about why pursue grad studies in cybersecurity and privacy, potential career paths, and then Q&A. Again, I'm not an administrator, and so if you have a lot of questions about details, about exactly how the requirements are for admission to the graduate school of UGA and all of that, I can give you a hint to the best of my knowledge. But of course, I can refer you to the right resources if you're interested in that later. Okay, so what is the Institute for Cybersecurity and Privacy and its mission? Basically the mission of the Institute is to really contribute to meeting the nation's cybersecurity defense research and education. Right? And the way we try to accomplish this is by forming this sort of hub at UGA for people, faculty and students who are interested in cybersecurity research and cybersecurity and privacy, both of them. The Institute has a designation as a Center of Academic Excellence for Cybersecurity Research given by the NSA and DHS. And there is a formal process that that we need to go through to actually prove that we have a sufficient research output, the number of research faculty. We are graduating PhD level students from our programs and so on to be able to obtain this essentially some form of accreditation in a way. And the Institute is really formally part of the computer science department, or it's a separate unit, but it's under the computer science department. And so I report, as the director, I report to the head of the computer science department. But more importantly, the academic programs related to cybersecurity and privacy are actually administered officially by the computer science department, and the institute really coordinates and collaborates with computer science and the curriculum and so on. So these are details on the administrative side, so probably not very interesting to you. But what I can say is that the institute is growing pretty quickly. So we currently have 7 core faculty who do research primarily on cybersecurity and privacy topics, spanning from network security, system security, IoT security, cyber forensics, AI security, trustworthy AI, and so on, and privacy in many forms. And we're planning to add 2 more faculty next year with 2 lines that have been approved. So on applied crypto and cryptography as well. And also we have affiliated faculty, so faculty who are affiliated to the institute but are not necessarily part of the computer science department, but they do research in other not necessarily technical topics that are related to cybersecurity. So we have faculty from math, economics, international affairs, law. There's a lot of research on cybercrime laws that are very important, and so on, and also engineering. So in computer science, we have about 1,300 majors, 180 graduate students. In CS, so CS graduate students working in cybersecurity and privacy, we have 25 students, 16 PhD students, and 9 master students. So these are sort of the student population. I mean, the numbers may be slightly different this semester, but more or less that's where we are. So it's a sizable community of faculty and students doing research or studying cybersecurity and privacy at the graduate level. All right, so this may be more of interest in you students. So this is how the MS in cybersecurity and privacy looks like. So you have to earn a total of at least 30 credit hours. You have 2 options to pass. You can take a degree non-thesis or thesis option. What does that mean? So the non-thesis, as the name says, you're not required to complete a master's thesis before you graduate. But you have to compensate for it with additional courses and the master's project at the end of the program. You see the list of the required courses. These are mostly for credit hour courses: cybersecurity, data security, and privacy. Computer system architecture is actually currently we are removing it as a requirement, but assuming that that's a prerequisite, meaning that you, as a student who applies to the program, you should already have a background that includes concepts in architecture, and then operating system, computer networks, and again, either the master's project or the thesis. These are all required. And then you have elective options that includes both sort of like advanced courses and things such as advanced cybersecurity, trustworthy machine learning, Internet of Things security, and so on. And you see them listed there. The last 3 courses that you see are not CS courses, are not computer science courses. They're sort of like multidisciplinary cybersecurity related courses in cryptography, threat intelligence at the sort of like business analytics level, and engineering, an engineering course in cyber physical system security. So what does that mean? It's basically, think about applications such as the security of the power grid, like the smart power grid. But there are many others, cyber physical systems that, like you can think of a water distribution system, right, for a municipality, right? Usually these systems, they're cyber physical because they're controlled by computers, right? Because there's a cyber component, and of course these systems are quite sensitive. You don't want to. In fact, there was an attack some time ago related to attempting to pollute the water of the county, right, in Florida, I think, by a cyber attack. So that's certainly something that it's extremely important. So there is a course related to this aspect specifically. All right, so that's for the courses, to give you an overview of the courses that you would take in our master's program. In terms of research topics that our faculty cover, we have a lot. So I'm going to just give you a very, very, very broad overview. So one of the topics is intelligent and trustworthy Internet of Things. So what do we mean? Internet of Things, IoT devices are all your Alexa smart speaker or Nest camera or Ring alarm system and so on and so forth. These are, typically small, at least at the home consumer level. They're small devices, right, that you typically have in your home, and that they're connected to the internet. They're, smart in a sense because they run software and sometimes sophisticated software. And of course, they are potentially exposed to attacks, right? And unfortunately, because of market forces, these devices tend to be, relatively cheap for what they do, and sometimes the manufacturers don't necessarily put a lot of effort or attention to security aspects of these devices, and thus they tend to be sold in the market with a good number of vulnerabilities that can be exploited for many nefarious reasons. I'd say, so you might have heard of baby cameras being hacked to invade the privacy of somebody's phone. All right. Another aspect that is very sort of like a hot topic is privacy. So we have one faculty who is an expert on differential privacy. I will not go into the formal details of what that is, but think of it this way. You know about, at least you have heard about AI and machine learning, right? So these systems, like the name says, machine learning, they learn to accomplish a task, like classify a patient at the hospital, to say this patient, according to the signs or like the sensors reports, may have heart attacks or essentially cancer patients and so forth. And so these systems need to learn from many examples of people who have taken tests, right, and have been diagnosed specifically by a doctor as being a patient of a certain kind. The problem is that applying machine learning techniques to these type of data, healthcare data especially, it's challenging because there are a lot of sensitive, there's a lot of sensitive information in those data sets. And often what happens is that the models themselves learn very specific details about people that can be extracted from the models if the models is distributed somewhere outside of, say, the hospital where the data was collected in the first place. Anyway, without going into too much details here, the important thing is that one very important research topic is how can we take raw data that is highly sensitive. We want to learn from it so that we can create this new wonderful technology that predicts whether a patient has cancer or not in an accurate way. But how can we learn these AI models without exposing the privacy of single patients, right? And so one potential way to do this is to first learn a model that instead of telling you if a patient directly has a certain specific disease, it generates another data set, let's say. And this data set is synthetic in a way, and the good thing is that it doesn't contain the privacy aspects of the raw data, but it can still be used to learn a classifier to predict the disease of a patient without exposing the single patient's private information. So I'm just giving you like a 10,000 feet sort of description of this topic. Also, it's not my research topic, so I'm not an expert in this area, but to give you a sense of the fact that there are a lot of important aspects related to AI and privacy nowadays that some of our faculty are trying to address. All right, so, and then we have several faculty, well, 4 faculty, I'd say, that that focus more on the software and system security aspects. So we have a faculty doing research in cyber forensics, software security on both mobile side and as well as IoT devices, and others. Another faculty who is working on automatic ways of finding software vulnerabilities by using software fuzzing techniques, for example, or in general trustworthy systems like Intel SGX and other similar approaches, and so on. And then faculty who work more at the lower level, closer to hardware security, so on IoT firmware security, and other sort of like operating system level security aspects. And then these are some of my research topics on. I mostly work on network security and web security. So detecting the presence of IoT devices in specific, maybe large networks, and denial of service attack detection, and detecting web attacks as well. And this is an example of the smart grid security research that I was mentioning earlier by Dr. Song in computer engineering school. So, and besides this, there are many other topics covered by faculty affiliated to the institute, like biometrics, cyber threat intelligence, cybercrime laws, software accountability, and so on and so forth. So, again, due to time, I will not be able to go into the details of all of these, and also I'm not an expert in these areas. But there is a lot of very interesting multidisciplinary research going on at UGA in cybersecurity and privacy. So it's a very exciting time, I think, to join. All right, so in the time that is left, I wanted to kind of like give you a sense of, an actual research project that my students are working on. I have 2 master students and a postdoc, and actually one of those master students is transitioning to a PhD program. And in fact, it's quite common. I've had many students who started as master students, and they like to do research so much that they transition to the PhD program instead. And so they started for the prospect of a 2-year program, but then because they did well and they enjoyed it so much, we were able to provide funding for them to continue for 5 or 6 years to finish the PhD program. And then you might say, wow, 6 years? Are you crazy? Why am I going to do 6 years in school, 6 more? And the reality is that if you look at the outcome, besides the fact that, of course, if you do those 6 years, it's probably because you like it. Otherwise, probably don't do it. But the outcome is really great. I mean, my experience has been that most of my students have been very successful. The vast majority of them went to Amazon as researcher or high-level software engineers doing some R&D, research and development in cybersecurity aspects. Most of them. I have had students going in the academic position at the University of New Orleans, tenure track, and very successful actually, which I'm quite pleased about. So doing research there, and so other besides my students, other students who recently graduated from our institute went to Facebook, went to other large tech firms, Salesforce or Square. So you might probably have heard of these names. You probably use some of those technologies. Okay, so that said, like I mentioned, let me give you an example of a research project that I'm working on. So before we start, I'm assuming that you have this background, so we'll go pretty quickly and just to cover the basics. So how does the web work? Let's say you open your browser, you type www.google.com there. What happens next, right? So some of you probably know already because you took networks classes. But the idea is that that domain name, that name google.com is called a domain name, will be resolved by the browser through a DNS query, a domain name system query, into a number of IP addresses. And that's sort of like, let's say, the first step. And then the browser will pick one of those IP addresses. I'm simply oversimplifying things, okay? But just to give you an idea, and contact the server somewhere in a Google data center, right? Typically, that to which the browser can send an HTTP request to get the web content, right? That would then the browser will render and display to you, right, visually. Okay, so that's basics. And of course, that doesn't work just for Google; it works for everything. And you might say, okay, so where are these? What are these IP addresses? I mean, where are they located? And whenever you contact or open a website, you have no idea where the server is located. You don't really care, to be honest, right? And you just trust that there is somebody on the other side who is a professional, set up the server in a professional way, and to offer the content and everything is works fine, right? The vast majority of the time. But of course, the internet is fully decentralized. There is no authority, right? Really, there is no internet police that can go and check who is a good guy and a good web server administrator and who is not. So you can have anybody register a legitimate looking domain name that resolves to an IP address that associated to a server, I don't know, somewhere in Eastern Europe, for example, or anywhere else in the world that hosts malicious content, right? And that malicious content, of course, can try to harm your computer. For example, compromise your browser, exploit some vulnerabilities to install malicious software, and then take full control of your machine. So that's sort of like the traditional sort of like basics, right, on web security. Of course, there are a lot of details that I'm skipping here. There are many aspects of web security. But I wanted to talk about one specific aspect, which is social engineering attacks. So when we talk about web security or cybersecurity in general, we always think about software vulnerabilities, right? So we think about an attacker trying to exploit a bug, right, a vulnerability in a software or system to take control of the system itself. That's the class. That's one of the. Usually the first thing that comes to mind. But the reality is that there are other attacks. There are attacks on people. So that's what we call social engineering attacks. These are attacks that try to exploit weaknesses in humans' decision-making processes. Humans are, software, of course, is complex. It's never going to be bug-free or vulnerability-free, at least not in a short time span, in the near future, probably. But there will always be a weak link, and the weak link is humans. Because humans can be tricked by exploiting their emotions, right? To accomplish a task on your computer that you really didn't want to, but you're tricked into doing so. And this can, of course, jeopardize the security and privacy of your machine data. And the attackers usually use tactics such as deception and persuasion, right, of different forms, enticing or allowing somebody to try to trick them into doing something they would otherwise do. Now, these social engineering attacks are generic. They don't only happen on the web, they can also happen in the physical world. For example, somebody can try to exploit a vulnerability, like enter a building, go into the reception, pretend to be a technician that needs to work on the telephone system, and then go inside and be authorized to go into a room that is supposed to be only for employees, right? Maybe connect to the Wi-Fi, implant a malware into the network, and then get out, right? So that's also a form of social engineering attack when the person uses all these tricks to convince the receptionist that there is an important job to be done, and so on. But I don't work in that area. There are books written on those things, but my research is on web, and one of the projects is on web-based social engineering attacks. So the main form of web-based social engineering attacks, which is everybody's familiar with, let's say, is phishing, right? Especially email phishing. You probably have seen it. Well, for the ones of you who filed for taxes, maybe something like this, right? It's quite common, or something of that sort. So email phishing is the most common means of trying to trick somebody, right? You click in a link that then takes you to either giving up your your username and password for logging into the IRS system, or your social security number, and so on and so forth. But there are other forms that may be more familiar to the young people in the room, like SMS phishing, right? I'm sure I've received many where there is a link in an SMS that looks potentially legit, but it's not, right? And when you click on that link, you might reach a website that looks legitimate, but it's not, right? And again, you may be giving up your credentials for your Apple, iCloud account. And there are also voice-based phishing attacks. In the interest of time, you can imagine how it ends, right? If the person engages with the telephone system, then it will be transferred to a real person, and then from then on, scammed into whatever. All right, so web-based social engineering attacks are social engineering attacks that happen on the web. So not email necessarily, not SMS in terms of the messaging itself, not voice, but you may stumble upon a page just by browsing that pretends to be something that it's not, or give you something that it will not give you. And so here's an example. So you're just searching for, you want to watch a movie. That's one of the main things that people do, one of them online. And interestingly, this was recorded a while ago. So this is a real example, okay? It's not made up. A user searching for a movie on a tablet, okay? And the first link that came up was for these fmovies.to domain that you might see here, okay? But people who are not experts in networks, they don't know what a domain name is. They don't even care, right? They just click on the link, they go here, and then click on the play button, and they see something like this, right? Now, this, for the ones of you, I mean, you could tell, for people who study technical topics, it should be fairly easy to understand that this is fake, right? The text, your Google Pixel sees 28.1% damaged. Makes no sense whatsoever, right? But you imagine like an older person, right? The elderly, they are not really, some of them of course are, but many of them are not familiar with technology. They don't know what that means. They get scared, they get alarmed by these messages, and they might click on the button, repair fast now, or whatever. And the reality is that whenever you click on this web page, that happens to you, and plus on the tablet, you don't see anything else, you just see that page, right? There is nothing else. So if you click on that, you might be referred to an app that may itself be malicious, right? So, and then you have a malicious app on your tablet. Of course, on your tablet, you have a lot of personal data, and a lot of things can go wrong. All right, so this is another example on the desktop browser of a tech support scam attack. Here, you're just visiting a normal website, and all of a sudden you have this pop-up, and that says that your Windows Defender has a warning for you, and you need to call Microsoft. And that number right there, and it turns out that that's a scam, meaning that if you call that number, you might be sold a technical support service that actually is meaningless for a good amount of money. There are other interesting type of attacks that are more passive, in that they don't show you a pop-up, that immediately alerts you or anything, but you're just looking for support, like technical support. And in this case, it's for an Amazon device, right? One of those IoT devices we talked about, a smart streaming, smart TV type of device, TV stick. And interesting thing is that the first link that pops up on Google is for a domain name that, it could be legitimate. Who knows? A third-party company that offers services, tech support services for devices of any kind. It's interesting that it's about Amazon, right? And it's actually a scam. It's confirmed it's a scam by human beings interacting with the people at that phone number that you see, right? So, and there are many. You want a gift, you want a lottery, you need to, give us your email address and date of birth and mailing address, will send you the gift card, right? All this information is going to be stolen. You're never going to get the gift card, of course, or the iPhone or whatever you want. So any questions up to here? And okay. Has anybody encountered any of these?
All of these.
All of them. Okay, cool. All right. So the good thing is that most people would recognize them if you're trained in a certain way, but a lot of people would not. All right. Now there is another interesting type or class of social engineering attacks that is more insidious. For example, say that you're searching something online, you click on a link, you get into this page. And what this page is saying is that there is some content that you need to watch or see, like a video to watch or something to see, but you need to click allow before you actually access that content. Now this you're, I think, all grown-ups here. This is often used for adult websites. I didn't put that example here for obvious reasons, but this is very often used for that. And many people will allow to be able to access the private content and all of that. So okay, why do we care? Well, we care because this is a browser feature, right, that you are more familiar with on your mobile system, which is allowing an app to send you notifications at any time, right? So here you're just allowing the browser to send you notifications. Well, and notifications, in fact, that website, that domain can send you notifications at any time, even if that page is closed. Like even if you have your Google page on, or your email like Outlook Online or Gmail or whatever you use, well, that domain can reach you at any time if you click allow. So what could happen? Well, you're visiting Wikipedia and you see something like that, right? You want an Amazon gift card or whatnot, right? And you might click on that, or something like this. Your Windows firewall is off. You need to turn it on. Why is it off, right? And then you click on that and you're engaged into social engineering and so on. And so, okay, so that's the background, just set of examples to understand what we're talking about here. And the research questions that we're trying to address are, okay, so we know that we see these scams online, but they're ephemeral, right? They don't, like, one time you see them, the next day they're not there on the same URL anymore. They change, there are different types. Okay, so what can we do? Because our browser doesn't stop them for us, not yet. So can we make it stop, right? So that's the question. But before that, well, what are these scams? Like, can we collect it? Because we need, we want to use, which is what we try to do, an AI approach to recognize these scams on behalf of the human beings before the human being interacts with these malicious pages. We need to train the system to recognize. And so the question is, where are they? And we collect them, many examples of them at scale, and then train the system for us to detect them automatically. So that's essentially questions that we asked. And so, so we had two papers that we wrote published in a conference called the Internet Measurement Conference. It's probably the top Internet Measurement Conference for academics in 2019-2020 on two different aspects, or two, sort of like one being the follow-up paper of the other, on how to collect, find and collect social engineering attacks on the web. Interestingly, these dear students who you see here who led the papers and our first authors, both started as master's students. And like I said, because they liked it, after 1 year, they decided to switch to a PhD student, to a PhD program. One of them, Fanny, is now a professor at University of New Orleans, doing really well as a tenure track professor there. The other, Kartika, is a postdoc with me right now, but she's looking for academic positions as well. So, so anyway, very successful PhD students, I would say. So very, very happy about it. Okay, so what did they do? And I will go fast here because I don't want to take too much time. I want to leave time to discussing, your questions. One thing that we did to collect those social engineering attacks on the web, like I said, was to focus on ad-driven social engineering attacks. So what do we mean with ad-driven? So you are familiar with online ads, right? So you might not be familiar with what delivers those ads to you. And there is a kind of complex ecosystem behind online ads delivery. And basically the way it works is that there are ad networks. So companies that specialize on putting ads on web pages online. Okay, so for example, let's assume that you are the New York Times and you want to monetize, of course, your content, right? You want to make money out of people exploring your, even just their homepage, which is not behind a paywall, right? You can, anybody can load the homepage of the New York Times. Well, those ads that you see on the top, on the, on the site and so on, they're not delivered to you by the New York Times. The New York Times includes JavaScript code in their page that will be a third-party JavaScript code provided by these ad networks, for example, Google DoubleClick, okay, that will, as you load the New York Times page, that JavaScript code will execute, will figure out who you are, right, and target you with advertisement, if it, either generic advertisement if you cannot tell, or a specific advertisement to you, right? And how will it do it? There is a complex mechanism with network requests that go through these ad networks to reach advertisers that actually want to put the content, the advertisement, on the publisher side. The publisher is the New York Times website. And there is a bidding process even, right? So where basically there is a request, a network request that goes out to a system saying, hey, somebody's visiting the New York Times web page. There is an ad space. Who wants to bid for it? How much you want to bid for it? And of course, this happens very quickly, right? It's like in the stock market, right? Everything is automated at this point, but somebody will bid for it, an advertiser. They will, you provide the ad to the ad network will provide it to the New York Times will provide to you. Okay, so I'm simplifying things by a lot, but more or less, that's how it works. All right, so what do we care? Well, the reason why we care is that there are a lot of ad networks out there. Some of them, let's say, are less trustworthy than others. What does that mean? It means that they really don't check who is the advertiser. They don't really care necessarily. They just want to make money. As long as they get paid, they can offer any content, right? And they say that in their terms and agreements that they check for malware, they check for anything, but in the end, we found in our research that many of them, either they have no means to, they don't, I'm not saying that they are necessarily illegitimate themselves, right? But they simply don't check or they don't have the technical means to do it well to block malicious sites. All right, so we found that there are a lot of these low-tier ad networks that are chosen by these social engineering attackers to distribute ads that lead to their social engineering attack pages. Okay, so look at that, this page right here. It's a normal, it seems like a legitimate page, right? There's nothing wrong. In fact, there are no ads here that you can see. However, there is some JavaScript code that runs in the background when you open that page that creates a transparent overlay for the entire page. Wherever you click on that page, it doesn't matter. Typically, people will click on the play button, right? Or it doesn't matter. Wherever you click, there will be another pop-up or a tab open that brings you to another page, which typically is what leads you to a social engineering. It displays a social engineering attack. In fact, these are, you cannot see it from here, but these are tech support scams. This is a malware download type of scam. Nowadays, you also have these fake notification buttons. These are not actual notification like I was saying before, which is another variant of the attack. These are just created by JavaScript. They look like notifications, and the reason why they do this is because people tend to pay attention to notifications. On your phone, you're trained on your phone to look at your notifications and click on it. Do something, interact with it, right? Here's the thing. If you click on this, it's not a real notification, but it will open another page that, this by itself, this notification by itself is a social engineering attack, right? Possible threats. There is no threat on your computer, not right now, not on the browser. You're always threatened, I guess, if you're connected to public internet, but this is really pretending that you have a malware on your computer. That's not true, not necessarily. So it's just fake, right? And all of this is done through code that publisher websites, which themselves be very legitimate, but they include to make money on their content. And then that mechanism for delivering legitimate ads is simply exploited to actually delivering malicious ads and lead you to social. So we built an entire system to automatically scan the internet to find the publisher websites, actually starting from the low tier ad networks. There's a cool thing that if you take a piece of JavaScript code, there's an engine, a search engine, which is called public.www.com. You take the piece of JavaScript, you put it in there, and it gives you a huge list of all the websites that include that JavaScript code. So what we did was to sign up for these ad networks, take their code, search it up, and find all the publishers that use that code, visit them with modified browsers that are do all automated clicks and browsing and all and whatnot, and then grab the pages, take screenshots, take all sorts of metadata related to the pages, the code, and so on and so forth, and then we apply machine learning type of techniques, clustering, and then basically do an analysis of all of these data and throw away the things that are actually potentially legitimate and keep the most likely social engineering related pages. So all of these being automated, and again, we're not going into the details. But one detail that I wanted to share with you that is quite cool is that my students have been working a lot on instrumenting the browser. So what does that mean? Modifying the browser code. So just to give you an idea of what that means, browsers. So this would be Chromium, which is the open source version of Chrome, which I'm sure you're familiar with. So browsers are extremely complex pieces of code. They are as complex as operating systems at this point. Like if you think about it, when you open a tab and load a web page, you're actually not loading. to us, it may seem simple, right? But you're actually running a web application. And when you have multiple tabs open, you have multiple applications running on this large software, which is the browser. There's isolation that needs to be kept between the applications because there are security sensitive, there's sensitive information, there are security policies that need to be enforced, right? Like, think about it. You are visiting, you have your bank website, web page open, or any other web page that has sensitive information, like your Facebook account or whatever. But then you have another tab visiting any random website. You don't want those to interact in any way whatsoever. You have a barrier. You want a barrier in between. So you want site isolation. So the browser provides that site isolation for you, and it's basically an operating system that runs multiple applications and keeps them isolated, right, from each other, so that the security issues don't happen. Okay, so it's a very complex piece of code. You're talking about millions and millions of lines of code to build a browser. Anyway, my students, what we did was to learn how to, first of all, understanding what the pieces of code relevant to what we wanted to do are in the browser, and then modifying them to basically extract the information or pilot the browser to automatically accomplish certain tasks that a human being would do. And then would be those two papers that I mentioned in this work of collecting the social engineering attacks. Really what we did was just to tackle that first block on the left. We have done nothing else, pretty much. Now we are working on the second block, which is taking the data that we can automatically collect and continuously collect. We don't stop. Like we have a lot of machines in the lab. We just let the crawlers run and to collect all this data. And then we are planning to do the learning in multiple ways, but right now we're focusing on the visual learning. So basically imagine, you have seen these examples of machine learning applications that can distinguish, can classify images. Okay, this is sort of like the basic blocks of self-driving even, right? Recognizing a stop sign, recognizing a pedestrian, and so on and so forth. There's a lot of computer vision there. There's a lot of deep learning, AI there. And we are using similar techniques to recognize social engineering attacks. Okay, so visually, just run the visual traits. And the intuition is that, think about it, social engineering attacks need to trick the human being, right? They have to be flashy. They have to have some visual cues to give to the user. But it's challenging because they can be rendered in many different ways. All right. So this is the sort of plan. We have basically we have done this. We're doing this part, and then eventually what we want to do is the last part, which is to build the models that we can embed in the browser to actually detect social engineering attacks in real time for everyone, for all of us, and alert us if nothing else, instead of blocking directly. All right, so so this just to give you an example of the type of research we do. There's a lot of technical. I didn't go into the technical details, but give you a hint with the browser modifications and whatnot, and the AI components. But in your day-to-day life, what can we do? Of course, be mindful of what websites you visit. It's not easy, but pay attention to the domain names that you're visiting. Is the page really trustworthy or not? If you're not sure, don't click on things, or certainly don't allow notifications and so on and so forth. But for you, really, more importantly, join the fight. And so one way to join the fight is a potential option, right? Is to join our programs at AUGA and do research with us at the institute. And in general, you would say, well, okay, so what if I don't want to do graduate studies? I want to go to industry, or what if I want to do graduate studies, but then I want to go to industry? So what's in it for me, right? The opportunities in cybersecurity are at this point endless. Really, I'm not. It's really, this is not hyperbole. It's real. there are so many opportunities that if you're good, first of all, you're going to make a lot of money. And this is real, okay? I mean, this is not made up. Millions of cybersecurity pros need it, right? Salary, whatever you want. Now, I'm not saying that you ask for $300,000 a year, they're going to give to you, at least not immediately. But if you prove yourself, they're actually going to give it to you. I know people who actually made half a billion, sorry, per year as cybersecurity experts. It's true. Okay, if you're at that level, you can actually almost get whatever you want. But besides those exceptions, what are the careers that you can pursue? Of course, the university career. If you do a PhD and you want to go into academia, that's a path. But besides that, this is a very interesting working for the US. You might not think too much of it, but besides the National Security Agency and the Department of Homeland Security and the DoD or the Department of Defense unit, there are also other roles. I mean, pretty much any federal agency or state agency you can think of has cybersecurity. Okay, like the Department of Energy has many programs related to cybersecurity to defend critical infrastructure for the nation. So this is a very interesting career path. There are also opportunities for scholarships for students, US nationals who study development studies in cybersecurity. So something to keep in mind. Industry careers, anything really. Banking or fintech, financial technology, they pay so much money typically to cybersecurity experts because of the sensitive nature of that sector. And then, of course, software internet industry like Google and Facebook and Amazon and others. And then energy, manufacturing, healthcare. How many hospitals have you heard of being attacked and compromised by ransomware? How many? Every now and then there is a story, right? They have a huge need for cybersecurity experts. So in terms of required skills, I put the obvious things there. Of course, coding. Okay. So let me say it this way. There are many paths for a career in cybersecurity. You don't have to necessarily have a career in technical cybersecurity, right? There are managerial aspects and sociological aspects, right? But of course, computer science. So I listed the skills for computer science people who want to pursue a career in cybersecurity on the technical side, and of course, very in-depth knowledge of those operating systems, networks, coding, software, and hardware as well. When you want to hack a system, you need to know how the hardware works as well.
Can you expand on coding and then when is one preferred over another, what your requirements would be?
I'd say you need to have all of them, but it really depends on what you do. For example, I mostly do network traffic analysis. So network security and analytics is my topic. So I'm not necessarily an expert in operating systems, for example. I know a lot about them, but I'm I don't have that's not my primary research topic, right? But in terms of coding, right, software skills, in any type of technical cybersecurity job, you will have to write code. If nothing else, scripts, think about complex Python scripts to automate penetration testing of some kind, or implement some exploit for some vulnerability that you want to test for, or for networks, scan networks in a particular way, right? That is custom, that you cannot just use an existing tool and click a button and have the results. That's really the main things that come to mind. if you want to do something that goes sort of like requires some custom tools, right? You need to write it. You need to modify tools that are already out there. That's quite common.
I guess what I'm more asking is to get into your program, what would they need? Are there prereqs?
Okay, so in terms of our program specifically, I would say that good knowledge of Python, good knowledge of, well, at least, some knowledge of C and C++, and, well, depending on what you want to do, a good, very good knowledge of C++. So if you choose the network security path and the AI security path, I'd say that knowing Python very well and some, basic, of course, decent knowledge of C++ is sufficient. If you want to go into the system security path, then very good knowledge, in-depth knowledge of C++ and operating system is a must. So it really depends on where you want to go. But to give you a generic answer, I'd say that knowing Python, knowing C++, having a good background on operating systems and networks. These are the four things. And of course, to really have a good understanding of operating systems, you typically have to have a very good understanding of architecture as well, for obvious reasons, computer architecture. And so these I would say these are the sort of like foundational subjects that you need to know to get into our program and be successful. All right, so that's all I had. Yeah, we're right on time. So, did you have any questions?
What does it take to apply?
So there is a process, and I'm not aware of all the details. So the UGA has the graduate school, and there are a lot of rules that you have to follow to apply through the graduate school. You can obviously find them online on the UGA graduate school website, but usually you have to have a certain GRE, right, that you need to meet, and then just to to be able to be considered essentially, and then your application, if you're applying to our program, would go to the selection committee, and then there basically they would look at your background in terms of what courses have you taken, your GPA, of course your GRE as well again, and then your letter of your statement of intent, why you are applying to the graduate program and what you would like to do, right? So these are the main things that they would look at to make a decision if you're accepted into that.
Thank you for the very I have a question about your recommendation when it comes to books about security. And what are some of your favorite books about security, technical or not?
That's a good question. So it's a bit challenging in the sense that are you talking about textbooks, for example?
Not necessarily.
Not necessarily.
Maybe it's a book about non-technical sort of security, a book about for lay people, or textbook is fine.
Okay. So the interesting thing is that so I'm just thinking about textbooks because by teaching the topics, but the interesting thing is that I would not be able to recommend a specific textbook for any particular topic. And the reason, like I talked to also colleagues recently about what textbook I would use. They're like, there's really no textbook that covers the topics that I want to address in my course. There are a lot of textbooks on cybersecurity, but they're kind of like generic. They cover a little bit of everything, but they don't go necessarily that in specific topics. So I don't have a good answer for you. I know that for my for cybersecurity, I used a combination of two textbooks. One is a textbook by Roberto and I forgot the other author's name, but it's basically an introductory cybersecurity textbook, and it was written for students who don't necessarily have a CS background. So it kind of covers the basic concept, and I like to use some of that for the undergrad, just at the beginning of the course to introduce some concepts, and then because I do network security, when I teach cybersecurity, I adapt the content to focus more on that, and so I typically teach a little bit of applied crypto. And so there are a lot of textbooks for crypto, for applied crypto. And then on the network security side, there is a textbook, it's called the Kaufman. I think it's Network Security in a Public World, I think. If I'm not mistaken, I might have mixed up a little bit the words, but the Kaufman, yeah, that's a very good textbook.
So, does the CS program at UGA have, do you have an REU program where undergraduate students can maybe participate in research and get introduced to this field? Maybe that can pique their interest in graduate studies?
I don't know if formally we do. I think that, usually what happens is that faculty who have NSF funding often apply for the funding increment for research, undergraduate research in UK opportunities. But it depends on it's sort of like on a ad hoc basis. We don't have a specific fixed program for that, but I'm sure there are opportunities.
You mentioned on there that if they get this degree, that the salaries and jobs are open wide. Do you find that any of them need certificates or certifications of any type to help them advance in that career?
Yeah, probably some do. It depends on what career path you choose in industry, especially, right? But also in the US government. To be honest, I'm not an expert on the certifications on the professional side, so I cannot really comment on that. What I can tell you is that our students, both masters and especially PhD, to my knowledge, have no certification whatsoever. But they get into these positions at Amazon or Facebook and so on, simply because of going through our program, and they do have high salaries.
Okay, so was a lot of your classes have Amazon labs?
There are the advanced, especially the advanced cybersecurity classes, they all require a project. Typically, the advanced topics classes are really more about research than teaching itself, in the sense that typically the faculty will deliver some, of course, instructional material, but a lot of the course is about reading academic papers and presenting those papers to show that you understand the content and you understand how to do research. I mean, at least how others have done the research, and then proposing typically a project of your own, alongside taking as an example one of the papers that you read, and then doing a project which includes a lot of coding typically, and then presenting the results of that mini research project at the end of the course. So yeah, so that's very hands-on. For the other courses, that of course there are labs, right? Meaning sort of like mini projects that we do throughout the course. I can tell you about networks, for example. I teach computer networks for grads. There are security aspects, of course, that we teach as well. There's a lot of coding there. I think we had 4 projects that the students had to go through, and with a mix of Python and C. Anything else? Well, like I said, I encourage you guys to look up the details of the program. Everything is available online, of course. It's it's easy to access. And if you're interested and want to shoot me an email, feel free. In terms of funding, for example, I mean, some people may be scared about even applying for graduate studies because of funding issues, but there are opportunities in different ways. So don't be immediately scared by that. And I mean, there are opportunities that can be explored depending on what you want to do, especially for PhD students, for example. The department typically offers some form of assistantship if you are accepted into the PhD program. So that's quite common. Not everybody gets it, but it's common. And then for the master students, it's a little bit more tricky in the sense that you might, typically the students that I have, for example, they typically do the first semester in which they're not necessarily funded immediately. But if they do well, they can easily, well, let's say reasonably easily find an assistantship of some sort, either within the department or outside the department. There are a lot of opportunities like, I don't know, veterinary school. They have nobody who can code, but they need cyber systems. Believe it or not, they work on databases or whatever research they do, whatever research projects on animal health or whatnot. They need computer science, right? So you can get a job within the university that pays for your studies, most of it, right? So there are a lot of opportunities. You just need to explore. Okay. All right.
Thank
Thank
you.
you.
So
everyone.